Hi, today we are going to discuss about the topic 0 of a polynomial. Let us understand this concept with a simple example. We can consider a polynomial p of x equals to x plus 8. Now, what value of x makes p of x equal to 0? That is, the value of the polynomial x plus 8 should be equal to 0. So as this is a simple linear polynomial equation, we can say that if we replace minus 8 in the place of x, we get the answer will be 0. So let's substitute that x is equal to minus 8. If we substitute a p of minus 8, we get minus 8 plus 8, which is equal to 0. Hence, we can say that minus 8 is the 0 of the polynomial. Remember, 0 of a polynomial is a number substituted in place of x makes the value of the polynomial as 0. In this example, the degree of the polynomial is 1, x to the power 1. So, we get 1, 0, that is minus 8. So, number of zeros will be equal to the degree of the polynomial. Here in this example, the number of zeros is 1 because the degree of the polynomial is 1. So, we can say that finding the value of x that gives us p of x equal to 0 is called the 0 of polynomial. Now, we are going to find the general 0 of first degree polynomial. So, we are going to take the general form of the first degree polynomial. The general form is p of x is equal to ax plus b. Now, and here a is not equal to 0. So, a is the coefficient of x and b is the constant term. Let us find the 0 of the general term. So, what value of x will give us this a of x will be equal to 0. So, we have to equate ax plus b equal to 0 to find the value of x. We'll equate ax plus b equal to 0. Transposing b to the other side, we'll get minus b, and transposing a to the other side, we get minus b by a. So, this value is the 0 of p of x. So, this is general term is minus constant term divided by coefficient of x. Here, minus b is a constant term and a is the coefficient of x. So, we can generally say that minus of constant term divided by coefficient of x. Now, we'll check this with an example. Now, let us take p of x is equal to 3x plus 9. You can find the value of x either by doing the equations or by using the formula we have found. We'll use the formula we have found. Here, the constant term is 9. So, we'll get minus 9 divided by 3. Here, the constant term is minus 9 divided by coefficient of x. Let us check our answer now. Substitute this p of x in the, substitute the x equal to minus 9 by 3 in p of x. So, we'll get p of minus 9 by 3 equal to 3 into, in the place of x, we are replacing minus 9 by 3 plus 9. So, we'll get 3 and 3 gets cancelled out and we get minus 9 plus 9, which is equal to 0. Okay, the next we'll solve the problems of exercise 2.2. The first sum is find the value of the polynomial 5x minus 4x squared plus 3 at x is equal to 0. So, you have to find the value of this polynomial when x is equal to 0. So here p of x equals to 5x minus 4x plus 3. So we have to substitute in the place of x, we have to substitute x is equal to 0. So let's substitute that. P of 0 equal to 5 into 0 minus 4 0 squared plus 3. So 5 into 0 is 0 minus 4 into 0 squared is 0 plus 3. So we get the answer as 3. We'll move on to the next sum. We have the polynomial is same, but here we have to find the value for x is equal to minus 1. So the p of x is 5x minus 4x squared plus 3. We are substituting x is equal to minus 1. So we get p of minus 1 equals to 5 into minus 1 minus 4 into minus 1 squared plus 3. So 5 into minus 1 is minus 5, minus 4 into 1 minus 1 squared is 1. So we get minus 4 plus 3. So the answer is minus 6. The next question is x is equal to 2. So in the p of x, we are going to substitute x is equal to 2. So p of 2 equal to 5 into 2 minus 4 into 2 squared plus 3. So 5 into 2 is 10 minus 4 into 2 power 2 is 4. So 4 into 4 will be 16. We have minus sign here. So we are putting minus 16 plus 3. So we get the answer as minus 3. We'll move on to the next sum. The second problem is find p of 0, p of 1 and p of 2 for each of the following polynomials. First one is p of y equal to y squared minus y plus 1. So we have to substitute in the place of y, we are going to substitute 0, 1 and 2. To find p of 0, we have to substitute y is equal to 0 in p of y. To find p of 1, we have to substitute y is equal to 1. We'll first do for 0. P of 0 is equal to y squared. So we are substituting 0 squared, y 0 plus 1. So the answer will be 1. To find p of 1, we are going to substitute y is equal to 1. So p of 1 equal to 1 squared minus 1 plus 1. So 1 squared is 1 minus 1 plus 1. The answer will be 1. Third option is we have to find p of 2. So we'll substitute p of 2. It is 2 squared minus 2 plus 1. So 2 squared is 4 minus 2 plus 1. So the answer is 3. We'll go to the second subdivision. P of t equal to 2 plus t plus 2t squared minus t cube. So we have to find p of 0, p of 1 and p of 2. P of 0 will substitute 0 in the place of t. It is 2 plus 0 plus 2 into 0 squared minus 0 cube. So we'll get 2 as the answer. Next we are going to find p of 1. It is 2 plus, in the place of t we have 1 and 2 into t squared. 1 squared minus t cube is 1 cube. So we'll get 2 plus 1. 2 into 1 squared is 2 and minus 1 cube is minus 1. So the answer is 4. Next p of 2. 2 plus 2 plus 2 into t squared, that is 2 squared, minus t cube, that is 2 cube. So 2 plus 2, 2 into 2 squared is 4. So 2 into 4 is 8 minus 2 cube, that is 8. So the answer will be 4. Next problem is p of x is equal to x cube. So we have to find p of 0 for this. P of 0 is equal to 0 cube. Anything 0 cube will be 0. And next one is p of 1. So it is 1 cube. 1 cube is 1. And p of 2. 2 cube is 8. And we'll move on to the next sum. It is p of x is equal to x minus 1 into x plus 1. So we are going to substitute p of 0 here. P of 0 is equal to the place of x. we are taking it as 0. It is 0 minus 1 into 0 plus 1. 0 minus 1 is minus 1 and 0 plus 1 is 1. So we get minus 1 as the answer. P of 1, 1 minus 1 into 1 plus 1. 1 minus 1 is 0 and 1 plus 1 is 2. So the answer is 0. 0 into 2 is 0. P of 2, substitute P of 2 in the polynomial, we get 2 minus 1 into 2 plus 1. 2 minus 1 is 1 and 2 plus 1 is 3. So we get the answer as 3. So in the next video, we'll solve the problems for the next 2 questions, verify whether the following are zeros of the polynomials and find the 0 of the polynomial.